Hi everybody. We're going to talk now about writing a quadratic function based on the zeros. Now, if you have one or two zeros and you have a parabola like this, then we can just write a really quick function based off of this. Now I'm just going to say, for the sake of argument right now, we're just going to say a is equal to 1, so we don't have to worry about what a is. Now, in this case, when your vertex is on the x-axis, so the vertex is on the x-axis, we have what we call a double root. And that will tell me that since I have a double root, what I'm going to have is that 0 is 3. So what I need to do is say x minus 3, and then x minus another 3. So I need two of them. If I don't have two of them, I can't just say, oh, x equals, or f of x is equal to x minus 3, because x minus 3 is a line. It's linear. So I need two. But since I only hit it in one spot, I'm going to need these two ideas right here. So we have a factored form. In this case, you can actually rewrite this as f of x is equal to x minus 3 quantity squared. That'll be your double root. So that's when your vertex is on the x-axis itself. We're going to take, if we see a root, we're going to take the opposite of what we see there. So we see the number 3, so it's x minus 3. If we look at this second one, I see x minus 3, I'm going to get x plus 3 as the root for this, or the factor for this, and then I have a positive 2, so I'm going to get x minus 2 in this case. So I'll get f of x is equal to x plus 3, x minus 2. So that's pretty much basically it. Once you see this, you just end up taking the opposite of whatever number it is and creating a binomial factor of x plus 3. That's going to be in our final answer. This one is x minus 2. Let's take a look at this guy. I have x minus 2, I have negative 2, so it's x plus a 2. And I have x is 10. The x-intercept is 10, so I'm going to get x minus 10. And so I can write, for a is equal to 1, x plus 2 times x minus 10. And if we wanted to check x plus 2, x minus 10 is equal to 0, this will tell us where our zeros are. So that's a 0, and that's a 0. So when we have that, we'll get x plus 2 is equal to 0. Subtract a 2 from both sides. X is equal to negative 2. Hey, there's our 0. If you get x minus 10 is equal to 0, add a 10. X is equal to 10. So we got our x is equal to 10 in that case. Now, here's a challenge problem. This is not quadratic. Oh, wait, we'll put it right here. It's not quadratic. But if we look through here, we can look and say, all right, every time we hit here, we have zeros. 1, 2, 3, 4. And here, we have 2. So if we want to examine this, that's 1, 0, that's 1. This is 2 because it hits the x-axis, it doesn't pass through it. This is 1, 0, and that's 1, 0. This is our double root right here. Now, just like we did here, you get to put in an x plus or an x minus the 0. for our function. And I would recommend just starting going left to right. The first one is negative 10, so I'm going to say x plus 10. The next one is negative 6, so I'll say x plus 6. I need 2 of the negative 4s because it's a double root, because like I said, remember, if it hits it once, it's a double root. So I'll get x plus 4 and an x plus 4. I have a positive 2, so I'm going to get an x minus 2. Positive 8, I'm going to get an x minus 8. So we have 1, 2, 3, 4, 5, 6 different functions. If we multiply this whole thing out, we get f of x is equal x to the 6th, etc., etc., etc. And this is a type of function that you would see for x to the 6th plus a whole bunch of other things all the way down to a constant number, which would be pretty big. But that would it's a very easy process to put these values down. And so as many times as it hits, that's what we'll end up getting. So you can build a function. It doesn't have to be quadratic, as long as you know what the number of roots are based on those roots. So we'll talk more about this in class. If you have questions, just let me know.